One thing you can be sure about when building applications for the cloud is that failures will happen. And when they do, they can potentially cause a pretty bad experience to your end users. Fortunately, .NET 8 comes with new libraries that make it very easy to introduce resilience strategies and patterns into your applications so that your customers never have to really deal with all those failures in the cloud. So today I'm going to show you how to use the latest innovations in .NET 8 to build resilient applications that are ready for the cloud. Here I have a couple of projects that should help us better understand what are these problems that may happen when we try to go into the cloud. And so first we have GameStore.Worker, which is a very standard background service that all it does is that every 1 second, it will go ahead and invoke one of the endpoints in GameStore.API. So GameStore.API is just a standard API, which is the dependency of GameStore.Worker, right? And so before we take a look at the code, let me just show this in action to you so that you get the idea. So first, let me go ahead and start my GameStore.API. And then when it's running, we're going to go ahead and also start our, over here, our worker. And what we should see is that every time the worker invokes the API, it's going to report, well, it is healthy, right? 200, okay, that's a response back from the API. You can also see how much time it took to complete the round trip, right? To go and come back. So pretty fast, it's all good. And so as usual, so this is what happens when you just run everything in your local box, right? But of course, that's not going to be the case when you go into the cloud. In the cloud, there are going to be problems, right? So what we want to do here is to introduce a little bit of problems into the backend, into the API, to see how our worker is going to react to that, right? So let's go ahead and stop this, and let's also stop that. So let me go ahead and open up our API over here and games endpoints.cs. So this is the file where we're declaring a bunch of endpoints, but really the main one that we're querying that the worker is invoking is this one here, which is the one that's going to return the full list of video games in this case, right? So what we're going to do is just to introduce a little bit of failures, and let me just copy this small snippet over here, there. Okay, and so what's happening here is that we are just calculating what I call the chance, right? So a chance which is going to go from 0 to 1. And so if that chance is minor than 0.2, then we're going to be introducing a delay of 5 seconds, right? So that to make the request just respond slow. And then if the chance is between that and 0.4, we're going to be just throwing an exception, right? So that it results in a 500 error. And otherwise, any other chance is going to result in just return the games, right? So now we have a little bit of random failures in the backend, and we want to see what happens in the worker when we try to invoke now the API. So let's go back here and let's rerun our API. All right. Okay, so it's running, and then let's rerun our worker. Right? And so this time, as you can see right away, we start hitting issues, right? So sometimes we're going to be getting these 500 internal server errors. Sometimes it is all green, it's all good. Sometimes we're getting this other problem, right? So 200, okay, but now we are taking 5 seconds to respond, right? And so we're getting a bunch of different issues. And so we need to figure out a way to not have all these problems, because of course they cause a bad experience to the end users. And also these problems, like for instance, let me stop this at this point. Things like this, waiting 5 seconds to report to the client is going to consume resources in our server, because those are threads that could be used for something else, but they are just stuck there waiting for the dependency to report back some results, right? So we cannot have this situation here. We need to shorten that. We have to do fail fast and return fast. How to do that? Well, for that, we can start using the new library available with .NET 8. Now, what library is that? So let me actually show you this page very quickly over here. So this is a page that talks about building resilient HTTP apps, right, with .NET 8. And if we scroll down here, this is a very nice page. You should take a look. It explains everything that we're going to be talking about in this video. But basically, this is the new package that you want to use at this point. So let me go ahead and just copy this, and let's head back into VS Code over here. And in our GameStore.Worker project, we're just going to go ahead and we'll paste what we just copied. So the package is Microsoft.extensions.http.resilience, right? And I'm using version 8 at this point. So let's go ahead and hit enter. All right. The package has been installed. Awesome. And so what that allows us to do is the following. So if we now go into our worker project, so let me show you how this is actually wired up right now. So we have program CS. What we do is we go ahead and register a typed client. In this case, I named it games client, right? So that's the class that knows how to talk to the API, right? And so it has been configured with the address of the API, which is at localhost 5115, right? And so just very quickly, what happens later is that we go ahead and register the hosted service, the worker, right? And this is the one that's going to actually go ahead and receive that games client via dependency injection, right? And then it is going to go ahead and when it executes, it's going to invoke the getGamesAsync method, which talks back to the API, retrieves those games, right? We are not doing anything with the game. We don't care really much, but getGamesAsync is able to actually log those lines to say what was the status code and how much time it took, right? And so after that, we just wait and we try again. So every 1 second, we can try again, try again, right? But what is really interesting here is that we can actually modify the way that this HTTP client is configured to add these resilient behaviors, right? So how do we do that? Well, now that we have the NuGet package in place, what we can do is the following. So we can go ahead and do this. We can say add resilience handler, right? And on this one, what you want to do is, well, first what you want to do is you have to define a name. It's a name for what we know as a pipeline, right? So let's just call this one my pipeline, right? And then you are going to go ahead and configure this handler with a bunch of options. Now let's receive here our pipeline builder. That's the object that you can do to use all of the configurations available, right? And now we have to define what is going to be the strategy that we want to use here, strategy or strategies. Now, like we said, we don't want to be waiting 5 seconds for one request to complete because it exhausts our resources. So we want to make sure that we wait at much, let's say 1 second. After 1 second, we just give up and we just fail fast to preserve resources. So to do that, what you can do is the following. Pipeline builder dot add timeout, right? A timeout, and here you can specify with how much time you want to allow here. So it's going to be time span dot from seconds. All right, it's going to be just 1 second right there. Okay, and so by doing this, we're saying that anywhere we use that games client over here, right, we're going to allow only up to 1 second for the request to come back, and otherwise we're going to fail with an exception. Right? So let's see how that goes. So we're going to go ahead and, yeah, the server is still running. So let's go ahead and rerun our worker and let's see what happens, right? So let's do this. And okay, so those are internal server errors. And then hopefully at some point we're going to start getting some of these delays. So let's just give it a moment. There it is. So as you can see, we started hitting these 5 second delays. And so since we don't allow that anymore, we go ahead and let me just stop this. And now we go ahead and stop at about 1 second, right? So error. So this means that we are failing fast. We don't consume resources. We just fail fast, return and say, well, this is not working. This is just in a bad situation right now, right? So that's one of the very first things that you should consider when you try to introduce resiliency into your applications. You cannot allow a request to just take too much time. Like I said, a bad experience for the end user, and then you just consume resources in your server. But of course, we don't want to end there, right? We still have the problem that we do have this timeout rejected exception, plus we still have these internal server errors that are screwing up every now and then our responses, right? So that's not good. So what can we do about that? What we want to do is probably to introduce a retry strategy, some sort of a retry behavior, so when something fails, we automatically just try again and see if we can get success. So how to do that? So what we're going to do is up here, and let me scroll down this a little bit. Okay, we're going to add another strategy. So what we can do is just say pipeline builder dot add retry, right? And so for this retry, what you want to do is receive what is known as HTTP retry strategy options. So new HTTP retry strategy options. All right. Okay, and so here is where you can specify all of these options that are going to be related to these retries. So the first thing, let's say how many times we want to retry. So let's say we want to retry, max retry attempts is going to be, let's say 5. All right, it's going to be 5. The next thing is, well, how much time we should wait between each retry. So there's a default of 2 seconds, I think, but let's say that we want to say the delay, we want it to be time span from milliseconds, just to make things a bit quicker, it's going to be 100 milliseconds, right? So this is going to retry up to 5 times and with a delay of 100 milliseconds between retries, all right? And then one more thing that we may want to add here is that we may want to add some logging, right, in the console, so just so that we can see that, okay, we are retrying, right? Something happened and we are retrying. Now for this one here, what you want to do is just use this on retry property here. And for this one, I'm actually just going to copy this piece over here because a bit verbose and I don't want to waste too much time typing there. Okay, and so what I added here, let me show you this. So it's a console write line, right? And so by the way, I'll be using console all over the place just because it prints nicely into the console. But certainly in a production app, you want to be using a proper iLogger, right? Now what we're going to say is, okay, so these arcs that come in that from that method over there is going to show us the attempt number. So how many attempts we have or what number of attempt is this that we're trying right now? After how much time we're going to be retrying once again, right? Total milliseconds, right? And then this last part is going to tell us that if it happened because of some status, I mean, the result was a failures result, right? So we have some status code like 500, or there was some exception that's just thrown on the other side. So we want to see what happened with that exception, right? Also notice here that the order is important, right? So I put this retry on top of the timeout because I want to make sure that if we time out, we retry because of that timeout, right? If we do it the other way around, it may not work this way, right? So I want to account for this timeout also failing so that we can retry on them, right? Okay, and so the next thing that I also want to introduce here is, let me add this, use jitter. It's going to be false. All right, and now I'm going to be talking about jitter in a second, right? I just wanted to set it false because for some reason, I mean, the default should be false, but from my experience, it's not really false. It's actually true, but I'm going to be talking about jitter in a moment, right? And so the last thing here, let me add one more thing here. Just put it here, is the backoff type, right? Backoff type is going to be delay backoff type exponential, right? And so this takes us into the exponential backoff pattern here. Now this pattern, let me show you this very quickly so we understand better. What happens with the exponential backoff is that, well, you have your app, you have your dependency, the client app talks to your app, and the app talks to the dependency, but it doesn't respond, right? It's just taking too much time. So we try again, right? But this time we're going to be waiting not just 2 seconds, we're going to be waiting an exponential time, 4 seconds this time, right? Before we talk into it again, right? And then we talk to it, and if it fails again, we wait not 4 seconds, we wait 8 seconds, right? We're waiting more time, right? Until hopefully we get a successful response. But if we don't, well, it just fails, and then that's it. But the idea is that we are not, we're giving it more and more time to the dependency to recover from the failures, right? And that just avoids overwhelming the dependency, right? So that's the main idea of exponential backoff. So not just linear, but we wait more and more and more time, right? And so if we rerun this now that we have an exponential, we're going to see the following. So .NET run. So let's see what we get. Okay, so we try, and then first retry, and right away, we're lucky. Notice this, and I'm going to stop it right now. So the first time it waited 100 milliseconds, but then the second time it waited 200 milliseconds, right? And if it kept failing, it will be 400 milliseconds, and so on, so on, so on, right? It's not the same time every time. So that's the idea of exponential backoff, and it's actually the default, right? So you might as well just remove this, and that's going to be your default, which is pretty good. Now the other thing is that we don't want to again just stick with that same set of cadence, right? So 100 and then 200 and then 400, because then every single instance that's going through this HTTP client is going to be using exactly the same times, and again that could overwhelm the dependency. So what you can do is now use this thing called the jitter, right? Use the jitter. The jitter is a way to introduce some sort of randomness into the invocations for those requests, right? So if we switch this from false to true, what's going to happen is that now it's not going to be on the clock, right? It's going to be a little bit less, a little bit more every time, so that the dependency is never overwhelmed by requests that are coming all at the very same time, right? So if we try this once again, let's see, what we should see is that we no longer have this on the clock retries, but are going to vary a little bit. Yeah, and we got lucky once again here. So notice that this first retry was at 80 milliseconds. The other one was at 160.03 milliseconds, right? And it's going to be varying significantly so that it is never the same time, right? So that's pretty much the main idea of the jitter, and it's all built into this retry strategy that we saw over there. So yeah, so that's all good. And so, but the problem is that, so that's great for retries, but what happens if the dependency is actually completely down? So a general outage, right? So what do we do in that case? So let's try and just stop our API, right? So now the API is completely stopped. There's nothing there. And so if we try running our worker, right? So go ahead and work. So of course it's going to be try, right? But then what? I mean, the dependency is completely down, so we can retry as much as we want, but it's just going to end up in this timeout rejected exception all the time, right? And so retrying this much is not helping anybody. It's actually consuming our resources, and so it's just giving bad experience to our customers. So we have to do something about it. So at this point, the recommendation is to use this thing called the circuit breaker. So what is the circuit breaker? So let me show you that very quickly. Let me stop this. So let's go into slides once again for a moment. Show you this circuit breaker pattern. The idea is that again, we have a client, your app, and your dependency, right? Now the dependency is having issues right now, and so when the client comes in with a request and tries to talk to the dependency, but this time we have this other component that we are going to be calling the circuit breaker, right? So it is tied into the web app. So the request comes from our app into the dependency. It's just taking too much time, and so we go ahead and try again. Again, takes time, and so the circuit breaker eventually says, hey, wait a minute, so this is just failing too many times. So we're going to be opening the circuit, which means that we're not going to be allowing any more requests out into the dependency, right? And so at that point, well, we just fail back into the client, but we're preserving the resources of our application, and we are avoiding to overwhelm again the dependency when we know that it's just not responding properly. It's just in a very bad situation, right? So the idea is that we're just going to be waiting for some time, and then eventually, hopefully, the dependency is going to recover. If we try again, we're going to be probing. So we probe in there and say, okay, so is this working now? So yeah, it is working. Okay, so we just go ahead and reopen we close the circuit, right? And that means that the responses can now nicely go back into our client. Right? So that's the idea of the circuit breaker pattern. It prevents our service from reaching resource exhaustion, and at the same time, it avoids overwhelming that dependency, right? So let's go ahead and see how to configure this circuit breaker with the latest thing in .NET 8. So let me close this. And so what we can do is, if you just scroll down here, what you want to do is the following. So what you want to do, pipeline builder dot add circuit breaker, right? And so in this case, what you want to do is use HTTP circuit breaker strategy options, right? And so, which can be configured in a fairly similar way as we did with the retry. Now, in this case, let me actually copy a few lines here to not take too much time. Right there. So these are some of the options that you can configure here, right? Now, what does this mean? So first we have sampling duration. It means that we're going to be measuring what happens during that time, during the last 5 seconds in this case. So if during the 5 seconds, right, we notice that there's this failure ratio. So failure ratio in this case, 0.9 means if 90% of the requests are failing during those last 5 seconds, right? And if we have at least 5 requests in this case, that's the idea of minimum throughput. If we at least have 5 requests, then we're going to go ahead and just open the circuit, right? So open the circuit, no more requests can go out, right? And we're going to stay in that state for at least 5 seconds. That's a break duration. We stay there 5 seconds, and then we're going to be sending a probe to see if things are back healthy. If they are, so the circuit is going to close and it's all good. Otherwise, we just, again, we wait 5 more seconds before opening the circuit, right? So yeah, so that's all you have to do to configure circuit breaker, and let's see how that behaves. So I'll go ahead and do .NET Run, and so once again, so we start trying, right? So we try and then we try again, and we try again, right? And so it's just too many failures, right? And so time rejected exception. Now it may take a little bit for the circuit breaker to kick in because it really depends on the right conditions, right? Yep. So as you can see, the circuit broke. I mean, we got this broken circuit exception right there, right? And the circuit is going to just stay broken for a while. I mean, I guess forever until the dependency comes back. Notice that eventually we try again, but once again, we get this timeout rejected exception because there's nothing on the other side. So we just keep going and keep going in that situation for a long while, right? So we're preserving resources of our application, and we don't try to overwhelm the other dependency because we don't know what's happening on that side. Now, eventually, right, our API is going to, well, come back, right? So .NET Run, it just comes back. And so hopefully our circuit breaker will notice that situation. Now it tried again, but again, we were unlucky. There was another timeout rejected session because it took too much time, right? Now we tried again. This time there was an internal server error, but luck. But eventually we proved and we got a 200, and with that 200, the circuit was happy, it closed, and it allowed those 200 OK to return back, right? So as you can see, we're back into healthy. We're back in the situation where we're just returning 200 status codes back into the client, right? So yeah, so that's the idea of the circuit breaker. That's how you can configure it. Okay, now there are a few other things that you can configure here if you wanted to, right? So for instance, over here, you could go ahead and also say, okay, so I also want to make sure that there are not too many requests going out, right, from my background service in this case, or my application, into the dependency, because I never want to really overwhelm the dependency. So what you're going to do is to introduce kind of a concurrency limiter. And so to do that, what you can do is just say pipeline builder dot add concurrency limiter. So for instance, if I do this, what it means is that it will never allow more than 3 requests to go concurrently into the dependency, right? Now, in this case, it will be a bit hard to demonstrate that, but just imagine that your web application may have tons of requests coming in at the same time. You may want to be talking to your dependencies again, also with that frequency, right? So with this, you avoid having to overwhelm the dependency, right? It's a very good practice. And so also taking into account that there will be a lot of retries and things when things go wrong, right? So that's another thing that you can introduce here. And one more thing that you may want to consider also here is a broader timeout, right? Because remember that we have a timeout configured down here, right? But this is a timeout for each instance. Each time when we retry, this is the timeout that we're going to be tolerating, right? But if you may want to say, well, that's good, but I don't want to allow, I mean, across all of these retries in grand total, I don't want to allow, let's say, more than 2 seconds for the whole thing, right? So if all of these retries and things we're trying there is just taking more than 2 seconds, just kill it, right? Just fail fast and get back to the client, because we cannot allow more than that. So for that, what you can do is just pretty much similar to what we did here. And I tell you, the order is important. What you can say is, okay, so I'm going to add another of these, a timeout. In this case, it's going to be from seconds, 2 seconds, right? And with that, we're saying that for all the retries, we are never going to allow more than 2 seconds. If that happens, we will just going to go ahead and throw an exception. So let's see if we can see that in action over here, if we're lucky. So yeah, timeout rejected exception. So there you go. So we should just never see anything more than 2 seconds going over here. So let's give it a moment and see if we can get into one of those situations here to see how it looks like. Yeah, as you can see right here, I'm going to stop it right now. So here it happened, right? So we error here with timeout when we try to go beyond 2 seconds there, because we're trying to retry things, but eventually it's just too much time, and we say, no, that's too much. I cannot allow more than that, right? So you always want to have these per instance timeouts, but also an overall timeout that is the much that you want to handle, right? Now, this is all good, and as you can see, it works great. But the problem is that, of course, you always have to remember that you have to put all these things in the right order with the right configurations. And so the good thing is that there is a method that's already introduced that simplifies this whole thing, that already includes defaults for all of this stuff, right? So instead of doing all of that, what you can do is just say, add standard resilience handler, this one over here, right? And so I'm actually going to comment out this, remove this for now, right? So just by adding this line here to your HTTP client registration, this is going to add defaults for all the policies that we just talked about. It's going to all of them introduce them right away into your client, so that you get all of these resiliency behaviors by default, right? So if we go ahead and just run this, what you're going to see is that, I mean, it's not going to be the same behavior that we just talked about, because this is using the defaults, but you're not going to see any failures also, right? You're going to see latencies, that's expected, but you're not going to see failures because we are retrying, we're doing the circuit breaker stuff, we're doing the rate limiting, we're doing the retries, all of these things are in place, and so the result is this, right? Always 200 OK, great experience by default. Now, if you wanted to, of course, you can configure it to accommodate for what you want to do. So I'm going to cancel this for a moment. And again, I'm going to be copying a little bit from here because it may be too much text. So if I copy and paste this over here, there, right? So what you can see here is exactly the same set of options that we set for each of the strategies before, but now it's all built in into this one options object for the standard resilience handler that you can see right there, right? So we have the rate limiter over here, we have the total request timeout. This is the timeout for the whole thing, right? We have our retry configuration right here, we have our circuit breaker configuration over here, and lastly we have our attempt timeout, so the timeout for each attempt, right? So if we take this here and we try this once again, let it run, you should see that we go back into the behavior that we had configured so far manually, but this time it's just one configuration, right? Which is, I think, is the best place to be in terms of resilience, right? So yeah, so super handy method. I think this is the one that most people want to enable for their applications, right? And so yeah, so that's already great. There's one more thing here that's actually is good, which is this one's called the hedging strategy. Now, what does that mean? So let me show you this very quickly over here. Go back to slides quickly. So what is this hedging strategy? So again, client, web application, and dependency. So the client will go ahead and talk to your application, and the application tries to talk to the dependency. But let's say that the dependency is slow, right? It's just taking time. The idea of the hedging strategy is that we have an application that really cannot deal with slowness. It really has to be fast. It always has to be fast. So what it would do is that even before that request ends, we notice that, okay, it's taking too much time. So let's go ahead and just fire something else, right? So right away we send something else. And then if that else is just taking more time than we are comfortable with expecting, we go ahead and send more requests, potentially in parallel, right? So we can send one or more requests to see which one of them is going to end the faster, right? So it's just a way to try very, very, very hard, I guess. And then whichever response is faster, that's the one that's going to win. And that's the one that we take, and that's going to complete our request, right? So again, main idea is that, so whenever we have one request that's just taking too much time, and let me put it here, yeah. So it executes actions, parallel actions when things are slow, and waits for the fastest one, right? So when one action is too slow, we just fire a bunch of others, as many as we need, and then whatever ends faster, that's one that we're going to take. So that can significantly really improve the performance of your application, right? And so let me show you how this actually works. So let's go down here. And what we're going to do is, well, instead of doing add standard resilience handler, what you want to do is, and let me remove this for a moment, is just say standard hedging handler, right? So add standard hedging handler. So that is the one that you want to use to configure this. Now we probably want to also configure all of those options that we all configured so far. So let me go ahead and actually add a little bit of that configuration over here. Okay, we're going to be using the configure method this time over there. Okay, so configure. So once again, we have the configuration for our rate limiter. We have our total request timeout. And then we have the section for hedging over here, right? And so the idea is that, I mean, it's a little bit different. What this means that here is that match hedging attempts is that how many actions you want to spin off when you notice that something is just too slow, right? And slow is defined by delay here. So in delay, I'm saying, for instance, here, I'm saying, well, you know what? If anything takes more than 100 milliseconds, I want to try again. Just whatever I tried originally, just try it again right away. Don't wait, just try again, because this has to be fast, right? I'm going to do this up to 5 times. That's the idea of this configuration, right? And there's just a little bit of logging in there just so we can see what's going on there. All right, so that's the idea of hedging. And then again, we have circuit breaker configuration. We have the endpoint configuration, timeout configuration also there. But let's see how this improves things a little bit. So let's go ahead and run this once again. Okay, and let me maximize this there. And so what you should see is that we should have very, very low latency at this point. No more really seconds or 2 seconds or 3 seconds. Is very fast, because as soon as we detect that anything is taking more than 100 milliseconds, we just right away send another request. Even when the first request is still ongoing, we just send another one and see if this one replies faster. If it replies faster, we just take that result and we go for it, right? And so that's what's making, as you can see, things are going way, way fast at this point, right? And so You want to be careful with this because it is going to send many requests in parallel potentially to your dependency, right? So, and also consuming resources because it is in parallel, right? So be careful with this. Only use it if you really need this amount of a speed in terms of your responses, right? But I mean, in fact, you can actually go even faster than this, right? If you say, you know what, anytime anything is taking more than 100 milliseconds, I don't want to just retry one time. I want to retry as many as possible right away because this is critical, right? So for that, what you can do is the following. Here, when we have the delay, we're going to say timespan dot 0. Right? When you put 0 here, it means that the moment that anything is going slow, just go ahead and fire 5 parallel requests at once. In this case, 5 parallel requests to try to recover right away, right? So we just not giving a chance to anything. So let's go ahead and see how this works. .NET Run. And so what we should see here is that really there should be like very little latency here. And in fact, sometimes the rate limiter also kicks in, right? As you can see, rate limiter may kick in because we are doing 5 parallel requests when we see that anything is just going too slow or there's any failures in the backend, whatever it is, right? So, but the end result, as you can see, is that 200 okay, all green, very low latency. So it's super fast. So it's a fantastic API. But like I said, you want to be very careful with this. It will consume resources in your application, and also it may try to overwhelm your dependency, right? So be careful with that. But yeah, so that's it. And so if you want to know more about any of these new strategies that are available here, what you can do is actually go into this page. Let me show you these. Resiliency strategies in polydocs.org, because by the way, this library that I showed you is really kind of a wrapper around the V8, the version 8 of Poly, right? It's not like .NET just tried to redo Poly by itself. What they did is that they added a nice set of APIs for .NET developers that in the end are going to end up reusing what Poly is already doing, right? So it is using the Poly libraries, but in a very nice way that so we can configure this very nicely in their .NET applications. But if you just go to this page, you're going to see a description of each of these strategies, right? And then there's links and samples and graphs and things into how to configure each of these, how they work, because there are many configurations in many ways to use these according to your needs, right? And so, yeah, so that's what I wanted to show you today. I hope that was useful, and I'll see you in the next one.